Alright guys, so we're in the last section of 8.7, or chapter 8, is using rational numbers as exponents. So first thing we're going to do is we're going to have a little bit of a review on exponents. So if you need more help with this, you should look at chapter 5.1 and 5.2 as a good review, if this isn't making sense to you. So first thing you got is you got the product rule. So the product rule is a to the m times a to the n equals m plus a to the m plus n. So you keep the base and you add the exponents. So if you have x to the third times x to the sixth, my bases of x are the same, so I keep it. And then I add my exponents, so I go 3 plus 6, so that would be x to the ninth. Alright, next one is my quotient rule. Quotient means division, so if my bases are the same, what I do to my exponents is I subtract it, so a to the m over a to the n equals a and then m minus n. So here's my example. If I've got y to the ninth over y to the fourth, my base is the same. I see that it's division, so I subtract my exponents, and it's always the top minus the bottom, so this would be y to the fifth. I'm going to give you another example of this. If I have 2 to the third over 2 to the fifth, my base is going to be 2. I subtract my exponent, so that would be 3 minus 5, which would be 2 to the negative 2. But remember, we can't have a negative exponent. So whenever we have a negative exponent, it says change me, change me. So I'm going to put it over 1 so I can flip it. And when I flip it, what happens is this negative exponent turns into a positive. So my final answer would be 1 over 4. If you don't remember that, go back to chapter 5.1 and 5.2, and there's some good examples from it. Now the last one we have is our power rule. So our power rule is a to the m raised to the nth equals a to the m times n. So when you have an exponent raised to another exponent, what you do is you multiply the two. So x squared raised to the fourth power, you keep that x and then you multiply the two. So 2 times 4 would give me 8. Okay, so this is just a review, but we're gonna apply this review to exponents of radicals. So if we have a to the 1 over n, so if a is a non-negative number and n is a positive integer, so if we have a to the 1 over n, another way that we can rewrite it is we can do the n root of a. So what we need to do first is we need to rewrite into radical form. So that means that square root form, or if it's the cube root, or if it's the fourth root, or if it's to the fifth root, etc. So we first have to write it in radical form, and then we can simplify it. So I've got 144 raised to the 1/2. So that would be the square root of 144, which we know 144 is a perfect square. So this would be 12. But I do need to see it in radical form first. That's going to be super important. Alright, now the next one, I've got 27 raised to the 1 over 3. So this is how I would plug it in my calculator, but I've got to write in radical form first. So, because there's a 3 right here, I'm looking at the cube root of 27. So the cube root of 27, it's a perfect cube, is going to be 3. Okay? And then the next one is I got 256 raised to the 1/4. First thing I got to do is write it in radical form. So we're actually looking at the fourth root here of 256, which that's a, how would you say it? A perfect fourth root of 4. But when you plug it into your calculator, literally it would be 256, up arrow, parentheses, 1 over 4. But I do need to see it in radical form first. Now, here's another one. So for D, it says negative 125 raised to the 1/3. So if I put it in radical form, that's going to be my cube root of negative 125. Okay, and the cube root of negative 125 is going to be negative 5, because 125 is a perfect cube. Now one thing I didn't explain on the other slide that I should have is if I have negative 5 squared and I have parentheses negative 5 squared, there's going to be two differences. These two answers are going to be different. If it's a cube root, then that negative is going to stay negative, but if it is a even root, or even exponent, then you have to make sure and watch your parentheses, because right here it says negative 5 squared. If you plug that into your calculator, you're going to get negative 25, because what your calculator is reading is the negatives on the outside and all they're squaring is the 5. So 5 times 5 is 25, so that's where we get negative 25. But if you have in parentheses negative 5 squared, essentially that's negative 5 times negative 5, which would be positive 25. And those two do not equal each other. So it's super important whenever you're raising to an even exponent that you make sure that you include your parentheses if you have them, which it'll make more sense when we get working with it. Okay, so if a is a non-negative number and m and n are positive integers, so we have the form of a(m(n) equals a to the 1 over n to the mth, and then we change it into radical form. So what you're doing is you're pulling out whatever that numerator is, and that's going to be the power that you're raising it to, and then you're going to change it into radical form. So remember, that could be the square root, that could be the cube root, that could be the fourth root, it could be so on and so forth. Okay, so let's look at this one. So we got 27 raised to the 4 over 3. First thing that we want to do is when we pull out that numerator, so of the exponent. So we got 27 to the 1 over 3 raised to the 4th power. Now, just like we were looking at before, if I'm cleaning up what's on the inside, this would be the cube root of 27. And then we'd put in parentheses, raising it to the 4th power. So the cube root of 27 is going to be 3. And then we raise that to the 4th power. And 3 times 3 times 3 times 3 gives us 81, which we can just plug that into our calculator. Okay? So what you essentially do is you pull out your numerator, you change it to radical form, you clean it up, and then you multiply. So let's try another one. So we got 16 raised to the 3 over 2. So first thing that we want to do is we want to pull out our numerator of the exponent. So we got 1 over 2 raised to the 3rd. So we literally pull that out. Then we change it to radical form. So this would be the square root of 16 raised to the 3rd. The square root of 16 is going to be 4 raised to the 3rd. And then 4 times 4 times 4 is going to leave us with 64 as our final answer. I do need to see this work. Okay, now we got negative 16 to the 7 over 4. That's going to be an even root, so this negative needs to stay on the outside. I'm sorry, an even exponent, so this negative needs to stay on the outside. So I've got negative, we pull out that 7, so that'd be 16 to the 1/4 raised to the 7th power. Keep that negative on the outside. This would be the 4th root, so this would be the 4th root of 16 raised to the 7th. So that would be negative, the 4th root of 16 would be 2 raised to the 7th power. And then 2 times 2 times 2 times 2 times 2 times 2 times 2 would be 128. And then the last thing we do is we bring that negative in front. So please, please, please be careful with that. I'm actually going to do another one just to make sure that we're good. So I've got D is negative 32 to the 4/5. So again, I see that I have a even exponent, so I need to make sure and be careful with my negative because there's no parentheses. So first thing I'm going to do is I'm going to pull out that numerator. So the negative's on the outside. 32 raised to the 1/5 raised to the 4th power. Then I'm going to keep that negative on the outside. I'm looking at the 5th root. So this would be the 5th root of 32 raised to the 4th power. The 5th root of 32 is going to end up being 2 raised to the 4th power. So 2 times 2 times 2 times 2 is going to be 16. So I've got 16. I bring that negative over and I'm done. So please be careful when you have negatives. If they're not in parentheses, keep it out until the end. Okay? So now there's one step with this, one step further. So if a is a positive number and m and n are integers with n being greater than 0, then so a equals negative m over n So what we're literally doing is we're going to have a negative exponent. So when we have a negative exponent, we're going to change me. So we're going to go 1 over m over n, and then we're going to clean it up from there. So this would be 1 over a. Remember, we would pull out the numerator. Then we change it to radical form. So this would be the n root of a raised to the mth, and then we'd clean it up from there if possible. Okay, and this is only when we have a negative exponent. Alright, now what we're going to do is we're going to make it real. So I've got 16 to the negative 3 over 4. So first thing I notice is I have a negative exponent, so I'm going to put this over 1, telling me to change me. So this would be 1 over 16 to the 3 over 4. So that's the first step that I do, is get rid of that negative. The next thing I do is just like we were doing before, I pull out my numerator. So I got 1 over 16 to the 1 over 4 raised to the third power. Then I turn it into radical form. So this would be 1 over the fourth root of 16 raised to the third, which would be 1 over the fourth root of 16 is going to be 2 raised to the third. So that would be 1 over 2 times 2 times 2 is going to be 8. And then that will be my final answer. So the only new thing that you have to do now is that you have to make sure if you have a negative exponent to bring it down. Okay, so let's try the next one. So I've got 8 to the negative 2 over 3. I see that I have a negative exponent, so I've got to change me. So this would be 1 over 8 to the 2 thirds. Then again, I pull out my numerator, so I've got 8 to the 1 over 3 raised to the second. Then I turn it into radical form, so this would be 1 over the cube root of 8 raised to the second. So that would be 1 over the cube root of 8 is going to be 2 raised to the second. And 2 times 2 will be 4. So my final answer would be 1 over 4. Hopefully you can kind of see the connection between these types of problems. Alright, so now what we're going to do is we're going to use the rules for exponents with fractional exponents. So what that means is we're going to use our product rule. So remember, our product rule is when we have a to the m times a to the n. So that'd be a m plus n. We're going to use our quotient rule. So that's when we have like a to the m over a to the n. We keep the base and we subtract. Or we're going to use our power rule, which is a to the m raised to the nth. So that'd be a to the m n, because we would multiply the two. So we're going to use those rules when we're simplifying. So we're going to write each answer in exponential form with only positive exponents. Okay. So I've got 7 raised to the 1/4 times 7 raised to the 5/4. First thing that I notice is that my bases of 7 are going to be exactly the same. So that's actually going to be my product rule. So I'm going to go 7, and then I'm going to go 1 over 4 plus 5 over 4. Now, when we're adding fractions, we've got to make sure and have the same denominator. That is the case here. So this would be 7, 4, and then 1 plus 5 would be 6. Remember, whenever we have a fraction, we have to make sure it's in simplest form. So this would be 7, and then both of them are even, so it would be 3 over 2. And now what we can do is write each answer in exponential form with only positive exponents. So you can leave it here, or you can clean it up like this. 7 to the 1 over 2 raised to the third. So that would be the square root of 7 raised to the third. Either one of these would work for me. Yeah, either one of those would work for me. Okay, now we got 11 over 1 over 3 divided by 11 raised to the 2 over 3. So my bases are the same. I see that it's a quotient rule, so I'm going to go 1 over 3 minus 2 over 3. So that would be 11. My bases are my denominators are the same, so I keep it. 1 minus 2 is negative 1. So the next thing that I have to do is I have a negative exponent, so I gotta go change me. So that'd be 1 over 11 to the 1/3. which would be 1 over the cube root of 11. Okay, so I'm using my quotient rule here to be able to solve this problem, and then I simplify it using the rules that we just went through. Okay, here's another one. It starts off by looking super intimidating, but I guarantee you if we talk through it, you're going to be just fine. You will see a problem like this on your test, and you'll see a problem like this on your final. So, same exact rules. So we got 5 raised to the 1/3 plus 2 raised to the negative 2/3 over 5 to raised to the negative 4/3. First thing that I notice is my bases are all the same, and I have negative exponents. So I want to fix those negative exponents. So this 5 to the 1/3, I'm going to leave exactly where it is because it's a positive exponent. But I'm going to bring up this 5 to the 4/3 because it's negative. Then I'm going to bring down this 5 to the 2/3 so that I can get rid of all negatives. So now I've got all positive exponents, which is great. So up here I'm going to use my product rule. So I'm going to keep my base of 5. I'm going to add my exponents. So 1 over 3 plus 4 over 3 over 5 over 2 to the 3rd. So this will end up being 5, and then my denominator is the same, so I keep it. And then 1 plus 4 would be 5 over 5 to the 2 over 3. Now I can apply my quotient rule. My base is the same, so I go 5 over 3 minus 2 over 3, which would be 5. My denominator is the same. 5 minus 2 would be 3. And we know that 3 over 3, any number over itself, is going to be 1. So essentially I've got 5 to the first power, but 5 to the first power is just 5. So super intimidating problem, but if we take it step by step, you should be just fine. Alright, and then the last one that we have is we have the power rule, because we have an exponent raised to another exponent. So let's read it first. So we got in parentheses p to the 1/5 over q to the 3/4 raised to the 3rd power. Okay, so this is a power raised to another power. So what I'm going to do is I'm going to turn this into a fraction to make it a little bit easier for us. So when we have a power raised to a power, we multiply the exponents. So we're going to keep the base of p. And when I multiply fractions, remember I can cross cancel if I can, but if not, I just multiply straight across. So 1 times 3 is going to be 3. 5 times 1 is going to be 5. On the bottom, I keep my q. 3 times 3 is going to be 9. 1 times 4 is going to be 4. Okay? Then I look at it a little bit more. My p and my q, my bases are not the same, so I cannot apply my quotient rule. And actually, this is as far as I need to take it. If you wanted to clean it up more, you could go p to the 1 over 5 raised to the 3rd over q. Ooh, I lied. We have to make sure and simplify this. So this would be, no, you can't simplify that. Okay, so this would be 1 over 4 raised to the 9th. So then this would be the 5th root of p to the 3rd over the 4th root of q to the 9th. I am totally fine with you leaving it right here. If you want to take it further, you can do that as well. Alright guys, so what I need you to do is I need you to do your 8.7 homework. Make sure you show all work and make sure you follow the directions, because sometimes you don't have to take it as far as you think you do. Alright, so make sure you follow the directions. Alright, that's it for chapter 8. So make sure that you finish this up, and then if you have any questions, make sure you bring them to class. Thank you.